Call is now being recorded.
Okay, so let's start with the questions. I think in this paper also we have like 10 questions. 1 minute. We have 10 questions. In general, we always get 10 questions. I think in one of the recent papers only, I saw that they gave you like 9 questions. But in most of the questions, you're expected to get 10 questions in P3. So if we start with question 1, this is about basic functions. In usual P3 questions, you will get two types of function questions. One is this type of input composite function. The other is that absolute value graph, where the equation is given in the absolute value format and maybe the graph is drawn and you have to work with the range and domain. Over here, they're asking you that write down the range of f. In this equation, this is a quadratic equation, right? We already know that in cases of quadratic equation, if the quadratic equation is given in the format of ax squared plus c, then your turning points, I mean, doesn't matter if it's the maximum turning point or minimum turning point, then your turning points y coordinate is going to be c, right? So over here, we got the y coordinate, of turning point. I'll just write TP, turning point, that is going to be C, whatever the value of C is. But if the question is given in the format of ax squared plus bx plus c, then there is no hint. I cannot get, or I cannot say that over here the C is your y coordinate for the turning point. This is your y-intercept on the graph, but never the turning point. So, I mean, it could be sometimes the turning point by coincidence, but by default, it's never going to be always the turning point over here. In this kind of cases, you have to do the completing the square format, right? Like write your answer in this format, and then you get the turning points coordinate as minus b and c. And from there, you can understand that, okay, this capital C is your turning points y coordinate. In this maths, over here, the question was given in this format, ax squared plus b plus c. The equation was given minus x squared plus 9. We can understand with the minus x squared. Just wait for 1 minute, please. Asha, so as I was explaining that from this minus x square, I can understand this is obviously a maximum graph, right? This is a sad graph. That means your maximum point is at 9. So if you want to find out the range for your maximum graphs, the graph structure or shape is going to be like this. The turning point is at y is equals to 9. Right, so I can clearly understand the least value of y in this graph that can be is your y equals to 9, and all the other values of y are greater than 9. So over here, your range is going to be greater than equals to 9, right? So your range, you finally can write that range over here is f of x, because they're representing the y as f of x, so f of x greater than 9. Right, all the other things I wrote over here, they're not necessary. Only writing this will be enough for you to get the mark. I think they're giving you 1 mark, right? So only writing this is enough. No need to draw the shape. explain this or any of these things. You don't even need to know, like you don't even need to say that if this is a maximum graph or minimum graph. I mean, that's just for you to understand, but no need to write this on the copies. If we move on to your part B, for part B, they're asking for composite function, right? F G 1.5. That means I have to insert gx into fx, and after that, I have to insert the value of x as 1.5 into the equation. So if we insert gf into fx, we have f gx. When we're starting with minus x squared plus 9, right? So from there, if I insert again f gx, inside this x square, I have to insert the value for gx, which was, by the way, 3 divided by 2x plus 1. So minus 3 2x plus 1 plus 9. I already know that over here the value for x is 1.5. So I'm not going to waste my time simplifying this equation by LCM or anything. I am just going to insert fg 1.5 and then 3 minus 2 1.5 plus 1 plus 9, right? And that's enough. You just have to now simplify the equation. 3 2 1.5 plus 1 plus 9, and you get 8.25. Wait 1 minute. Oh, sorry, there we had a square. On top of this entire fraction, we had a square, so square, now we get actually 8.4375, which in fraction gives you 135 divided by 16. Okay, so that is the value of your FG 1.5. Tashdid, is there any problem up to question A and B, 1A and B? Tashdid, are you in class?
Yes, miss.
Okay, in part C, they're asking for the inverse function. Try to write down the inverse of gx. Yeah, other than that, nothing else, only giving you 3 marks for it. Okay, so in general case, for your inverse function, we always consider the fx to be y. So we'll write that, okay, let gx be y. If we are considering that gx to be y, then we can write that y is equals to 3 divided by 2x plus 1. I'm obviously going to take the denominator to the left hand side. So we get 2xy plus y, or yeah, 2xy plus y equals to 3, and from there I just have to keep x to the right, to the left hand side of my equation. So which gives you 3 minus y divided by 2y, right? So this is your equation. Now we get x is equals to 3 minus y 2y. This is in the inverse, this is actually your inverse function, but in terms of y. But I was asking for the inverse in terms of x, so I'm going to, like, take the same equation and write g inverse x. I'm going to replace y with x, right? That's just it. Other than this, nothing else to, you have nothing else to do. 3 minus y divided by, so 3 minus x divided by 2x. And this is it. This is your inverse function, right? Other than that, no, other than that, they didn't ask you for anything. X is a set of real numbers, x is greater than 0, and yeah, nothing else. So this is your inverse function. After this, we're done with question 1. Let's move on to question 3. Rajdeep, any problem from question 1?
No, miss.
Okay, then we'll quickly move on to question 2. Question 2 is about mixed of trigonometry and basics thing. I think a little bit of differentiation from this part. It says that fx cos x plus 2 sin x, express fx in the format of this, where r and a are constants. It is given that r is greater than 0 and within the range of pi by 2 and 0. Okay. And given that the exact value of r, give the value and give the exact value of r and give the value of a in radians to 3 decimal places. Okay. Cos x plus 2 sin x, right? So that means over here, we are using that formula, r minus cos, express fx in the format of r minus x minus a, right? X minus a, in general case, what was the formula for cos a minus b? It was cos a cos b plus sin a sin b, right? Yeah, cos a cos b and sin a sin b. In that case, r cos a cos b. When in the given equation, it is say that the answer should be in this format: r cos x minus a. So in general case, for normal x minus a, we always write the equation as cos x uh, cos x cos I think that's alpha, I think. Yeah, cos x cos alpha, then again minus plus sin x sin alpha. So we can write this as fx r cos x cos alpha, and then again plus r sin x sin alpha. And this was exactly written in the equation as cos x plus 2 sin x, right? In your equation, this was written as cos x plus 2 sin x. So from there, I just have to now do some um, comparing in this case. I can rearrange this equation and write this as cos alpha cos x. I can see that cos x coefficient over here was r cos alpha, and in this case it was 1. So I can say that comparing, we can write r cos alpha is equals to 1. So we basically get the value for r as 1 over cos alpha, right? And then again, if you again compare the sin x, I'm also going to replace the sin alpha and x. I can again see sin x coefficient was 2, sin x coefficient was r sin alpha. So I can write r sin alpha equals to 2, and from there again I can write the value for your r as 2 by sin alpha. Right, so over here also r becomes 2 by sin alpha. In this case, by the way, I'm supposed to find out the value for r and alpha first, and then maybe write down the wait, given the exact, sorry, this is another part, I think. Yeah, we're supposed to just find out the value for r and alpha. Okay, so for r and alpha, I can understand this is my first equation, this is my second equation, this is my first equation, this is my second equation. So I'm going to substitute 1 into 2. And if we substitute 1 into 2, we basically have r equals to r. And from there, I can write 1 divided by cos alpha. And this is 2 divided by sin alpha. So again, if I take sin alpha to the right-hand side, we basically have sin divided by cos, sin alpha divided by cos alpha equals to 2. And from there, I can get how much? Tan alpha equals to 2. And again, from there, alpha becomes tan inverse 2, right? Yeah, tan inverse 2. So if you calculate this, tan inverse, 1 minute. Yeah, in terms of radian, I think I have to do the maths because this was your hint. The value for your alpha was given as pi by 2 and 0. So we should calculate this in terms of radian. Otherwise, if you calculate this in degrees, you get the answer is 63.4 roughly. So if you calculate this in radians, tan inverse 2, you get 1.1047, so 1.1071. And it was also stated that, find out the exact value of r. That means r should be kept in some type of surds format, but alpha should be kept in decimals places. So in that case, obviously, your value for alpha over here has to be calculated in radians. Okay, so tan inverse is actually 1.107, three say decimal places, right? Yeah, so 1.107. You get 1.107. This is the value for your alpha. And then again, we're going to substitute this into any one of the equations. So if I substitute alpha into maybe equation 1, we get r equals to 1 divided by cos 1.107. So we can write 1 divided by 1.107, and that is 2 point, okay, 1 minute, 1 divided by cos alpha is tan inverse 2. Yeah, we get 2.2361. 1 minute. This is the exact value of root 5 actually. I mean, if you calculate this, this is how much? Tan inverse 2 inside cos. Tan is actually sine by cos. So eventually sine and cos can, like cos and cos cancels out. So you basically have 1 divided by sine inverse 2. No, that's a math zero process. 1 minute. Yeah, I mean, I just have to, carry out the exact value. That will give you the exact value of your R. Over here, 1 divided by cos, that was the answer. So I'm going to write cos alpha it was. So over here inside of alpha, I got tan inverse 2. So I can write this as 1 divided by cos tan inverse 2, right? So we calculate this, then you'll get the value for your R as root 5. Now you can keep your answer, I mean, write your answer in the format of R cos x minus alpha. So we can write that f of x, R is now root 5 cos x minus alpha is now 1.107, right? So this is all the working you need to do just to convert your equation from cos x plus 2 sin x in the format of this. Tajdeep, is part A clear for you? Question 2A, any problem?
No, miss.
Okay, then we are done with question 1A. After this, they've given you this gx equation, 3 minus 7, 2fx, right? We have to do some translation stretching basically. So there they're asking that given that answer to part A, write down the exact maximum value of gx. Okay, maximum value of gx. One thing to understand is that I am multiplying minus 7 f of 2x, and then I'm going to add 3 over here also, right? So what type of translation can I expect from here? I can expect that y coordinate, like the graph is going to be again what? Entirely reflected on the x-axis because we have a minus here, right? So we basically have x coordinate multiplied with half because of this 2, right? So over here for 2fx means that x coordinate will be multiplied with half, and your y coordinates over here is going to be minus 7y plus 3. Okay, y coordinate is going to be multiplied with minus 7 and added with plus 3. That was the basic rules of your translation stretching, right? So now over here, how many marks they were giving you? I think 2 and 1 and 2 or something like that. Write down the exact maximum value of gx. Cos x minus a, we got the value for a, but wait 1 minute. If we take this, I understood that, okay, from this type of pattern, I have to solve the equation. We're basically somehow stretching this equation, like gx was given in this format, minus 7 f2x, so it is already written over here. So this is actually f of x. F of x was further stretched into minus 7 f2x plus 3, right? This equation is modified into your minus 7 f2x plus 3. In this equation, f of x was actually previously written as root 5 cos x minus 1.107, right? This is what I got in the previous part. From this part, I can understand that over here, they're only asking you for the maximum point, right? 1 minute. Maximum
Miss.
value of gx. That means they're asking you for the y coordinate, yes?
For this type of question, they are asking for maximum or minimum. Can
Hmm.
we just like differentiate it and then find the value of the maximum or the minimum?
I mean, this is a cos graph, right? For cos graph, the graph only have like two turning points, one maximum and one minimum. Why would you differentiate this? Problem is, even after differentiating this, they're only giving you 1 mark. So we have to understand the process. They, if you want to differentiate them, that's a very lengthy process, right? You have to carry on with the differentiation, like, consider dy by dx equals to 0, and then find out the x value, then insert the x value into fx or gx over here in order to find out the y coordinate, right? So that's like a 4-step maths. No, they're only giving you 1 mark for this. So you wouldn't carry out a 4-step math just for 1 marks, right?
Okay.
Another thing, this is a cosine graph, right? For cosine graph, I can clearly understand that their turning points for the positive coordinate or for the negative coordinate is always at equal values, right? So next, from this part, I can actually understand that where the turning points are going to be. In this case, first thing, there's a problem that this is actually an entirely inverted graph, right? Whatever the maximum point was for this graph, this graph, it will be the minimum point, right? And whatever the minimum point was for this graph, that will be the maximum point for this graph, because this is an entirely inverted graph. Whenever you multiply minus with your fx, this minus will entirely invert your graph over the x-axis, right? As you can see, maximum graph for the original graph, but it becomes the minimum for the translated. Minimum for the original, it becomes a maximum for the translated. So they are asking you for this value. So if they're asking you for this value over here, from this part, if you want to find out that where would be your value for what was that value for the turning points are going to be, in this case, minus root 5 was multiplied with this equation, right? You have to understand that, okay, whatever your x-axis were, right, x-axis were always subtract, like added with that 1.107 according to the translation, right? X minus 1.107 means that on your x-axis, for all the x-axis for this equation, 1.107 has to be added with that. And this root 5, what does it indicate? It indicates that minus, when root 5 y, right? That becomes the turning point values. Originally, for cos graph, the maximum point is 1, the minimum point is -1. We can understand that if root 5 is going to get multiplied with 1 and -1, so I do not know exactly what the x coordinates are going to be over here, but the y coordinates, maximum point y coordinate is going to be root 5 multiplied with 1, we'll just keep it like this, and multiplied with -1 will give you minus root 5, right? Not focusing on the x-axis this time, because they were only asking you for the y coordinate, so we are not focusing on x-axis. And again, over here, if I want to convert this one, this is going to be my maximum point. After multiplying -7, this was your hint that if we have a -7 over here, that means the maximum, so minimum point of the original graph will become the maximum point of my translated graph. That means over here, how would I write down the equation in this case? It will be actually half x plus 1.107, and then again your -7y plus 3, right? This is how I'm supposed to write it. But again, I'm not focusing on the x coordinate. We're not interested in that. But for the x coordinate, I'm just going to write like this is something there. But for the y coordinate, if I write -7 minus root 5 plus 3, and that leaves you with 7 root 5 plus 3. So all these working, you don't have to write all these things. You just have to write that maximum value of gx is just 3 plus 7 root 5, right? Writing this much is enough. Other than this, nothing else has to be written. Tajdeed, is this clear? You have to understand all these basic things, but you don't have to write this on your copy. Only writing this is enough. Tajdeed, any problem?
Miss, 1 minute.
Okay, sure.
Miss, can you just highlight the which part we have to write only for this 1 mark?
Oh,
1 mark.
1 minute. Just this maximum value. But they were only asking for the maximum value, you just have to write this down. Other than that, no other workings are required. right? All these parts where your rough work, this is the only part that you have to write.
Okay, miss.
Okay, then if there's no problem, then we'll quickly move on to part. This was actually B1. This is your part B1. After this, if we move on to part B2, they're asking that find the smallest positive value of x for which this maximum value occurs. Give your answer to two decimal places. One thing to understand again, for part B2, f of x, obviously we understand, was translated to -7 f 2x plus 3, right? From there I understand that for f of x, for f of x also, it was not the original cos x equation. That was also a little slightly a translated equation from cos x, right? I mean, in general case, we always work with just cos x, but over here I was working with root 5 cos x minus 1.107, and in this case I was actually working with cos, so 5 multiplied with so 7 multiplied with root 5, so basically get 7 root 5 cos 2x minus 10107 plus 3, right? This is how everything got translated over here. So I understand for cos x, the equations were obviously, I mean, the coordinates were just x and y. For root 5 cos x minus 1.107, for this it was actually x plus 1.107 and root 5y, right? Further, when I translate this as 7 minus 7 root 5 cos 2x minus 10107 plus 3, over here your x coordinate was actually multiplied with half x plus 1.107, and your y coordinate was we previously calculated minus 7 root 5y plus 3, right? This is how the coordinates are going to be. This is the y coordinate, x coordinate, because they got translated. Now in this equation they were asking you that, find out the maximum point, like this maximum point occurred for which values of x, but over here we're asking for the smallest value of x. Okay, I think smallest positive value for x. Yeah, smallest positive value. Smallest positive value means, I mean, if you draw the graph for your cos x, this is how the graph looks like. I think cos 0 is 0, 1 minute. Cos 0, no, cos 0 is 1, sorry. Right, this is how the graph looks like. What you can understand is that you get this maximum value at 0 coordinate. You again get this maximum value at 360, or which is 2 pi over here, right? Cos 2 pi is 1, right? So you're getting the same maximum value at 2 times 0 and 2 pi. But then again, if you continue with this graph furthermore, you can again get this as how much? As again at 4 pi, I think, right? Cos 1 minute, 3 pi minus 1, then cos 4 pi is 1, right? You can again get this as 4 pi, right? So if you continue with this graph, you can always get this value for 1, like for 2 pi, 4 pi, 8 pi, for 16 pi, for all these values. But what would be the smallest value of x? At first, this at first you get the cos graph as the maximum point. This is the first smallest value of x for which you get the maximum value, right? Smallest value and non-zero value, right? Obviously, you get the maximum point always at the 1 or always at 0, but the first positive value is 2 pi. So this is the graph that we're going to modify over here. This is the point we're going to modify over here. So if we start with your equation, I already understand whatever the maximum point of this graph was for cos x, that will get so what was the minimum point for this graph was, that will be the maximum point over here. The minimum point was actually at -1, and I think it was at cos 90, so cos 180. For cos 180, we're just working with cos pi. So I'm not going to waste my time trying to find out cos 0, 1. Then when the value for cos equals to 90, it was 0. I'm not going to write all those coordinates. I'm going to entirely focus on my coordinate pi minus 1, because I can clearly understand this graph or this coordinate will be the maximum coordinate of this translated graph. When you translate this to this equation, it becomes pi plus 1.107 and negative root 5, right? And if you convert this into your final coordinate, it will be half pi plus 1.107, and then obviously we got the coordinate already. It was 3 plus 7 root 5, so we can write 7 root 5 plus 3, right? So we got this value. This is your final case. This is your actual answer over here. If you write this down, I mean, I'm not actually supposed to write it like this. We're supposed to write it like this. Sorry, 1 minute. It was supposed to be x plus 1.107 divided by 2. So if you write this down, it's going to be pi plus 1.107 divided by 2. So if you want to find out the x coordinate, this is your final answer. It was supposed to be written in terms of decimal places, I think. 1 minute. Yeah, 2 decimal places. So I'm going to first write obviously that pi plus 1.107 divided by 2. So then we can write pi plus 1.107 divided by 2, and that gives you 2.124, or I can write 2.12, right? This is my final answer. And over here also, I'm supposed to only write this x coordinate and not explain the entire translation over here, okay? Never include the translations. They're only going to give you marks for this x coordinate and for y coordinate, not the working over here. This is it. This is your part B2 calculation. Tajdeep, any problem from question 2?
No, miss.
Okay, then if we move on to your question 3, this is about logs exponential, right? I can clearly see that figure 1, L1 shows the linear relationship between log 10y and x, and I can clearly see they intersecting at 2 points, 0, 1.5 and 4.80. So write down the equation for L. Okay, I mean, we have the 2 coordinates. I can easily find out the gradient over here. For the gradient, it will be 1.5 divided by 4.8, right? Negative 4.8. Sorry, it will be positive 4.8. So your gradient here is just 1.5 over 4.8, and you get 1.5, 4.8. So you have 5 over 16. I mean, you get 0.3125, but 5 over 16 is going to be easier for your calculation. Now, if we start with the equation for line L, then you can write this equation as a log 10 y, then the y, I mean, you can take any coordinate over here. I'm going to use this coordinate, 0, 1.5. So you get minus 1.5, and then again 5 by 16, x minus 0, right? Over here, the answer, they didn't give you any format that in this format you're supposed to write down the answer, but I can write this as log 10y 5 over 16x plus 1.5, and after this I can write my answer in terms of y also, right? Over here, if I want to keep my answer in terms of y, we have to do the logs basics, that whenever this base of log is shifted to the right hand side, everything on the right hand side will become the power of this log base, right? So it will be 10 with the power of 5 by 16 x plus 1.5. Can you guys just wait for a minute, please? 1 minute. Okay, as I was saying, I can keep my answer again in this format, or I can also furtherly explain, explain the entire power, split the entire power. So if I split it, I'm going to get 10, 5 by 16x. We have a plus here. That means obviously this was multiplied with another 10 power 1.5. I can break down 10 power 1.5, right? 10 power 1.5 is actually 31.622. So I can write this entirely as 31.622 into 10 power, or I can write this as again in brackets, 10 power 5 by 16x, or I can also write it in this format. Whatever format is easier for you to work with, you can just keep your answer in this format. This is it for your part A. We're done with your equation for line L. After this, they're asking that hence or otherwise express y in terms of this. Oh, okay, sorry. For part B, it was supposed to be like, this derivation. So I'm going to separate this. This was actually the working for your part B. You're not supposed to do that for part A. For part A, I'll just write down the equation. Okay, this is my equation and that's it. Not simplify it in any way. But for part B, it was stated that your answer should be in the format of y is equals to kb power x. So I'm going to consider this as part B. So over here, I'm just supposed to write 31.6, right? Because in this question, it was already stated that your value for b over here was in three significant figure. So I'm going to introduce another line, 10 to the power of 5 by 16. Not introduce, I'm going to write down that another line. That was 10 to the power of 5 by 16x multiplied with 10 to the power of 1.5, right? And then I broke down this 10 to the power of 1.5 and wrote it in the front as three significant figures, 31.6. This is it for question 3. We don't have to explain or write any more other than these things. This is it. Then we'll move on to question 4. Tajdeed, any problem from question 3?
No, miss.
Okay, then if we move on to question 4. Question 4 is about what? Simplifications, right? Part A is simplification, part D is normal integration. So if you're starting with this, x power 4, 15x squared, 35, 21 minus 4. I can understand even if I do long division over here, I won't get exact value, right? Over here, we have x plus 3 and x plus 3. X plus 3 whole square means that we have two factors. Like both of the factors over here are x plus 3. So if I write, just 1 minute, please. Okay, so as I was saying, we basically have the equation 2x power 4 and then 15x power 3, 35 x square, and then 21x minus 4. Everything was divided with that x minus 3, right? X plus 3, right? When we have x plus 3 whole square, that means x plus 3 and x plus 3. So if I now start do the long division with x plus 3 only, is there any other way I can do? They're only giving you 4 marks. X square bx plus c. We can do the comparing method also. If you want to do the long division, obviously the long division is possible. But if you want to skip the long division, there's another process that's available. We have this x plus 3 whole square here, right? And this is equivalent to ax square plus bx plus c plus d divided by x plus 2, so x plus 3 whole square, right? So which means that if I take this to the right hand side, it will be multiplied with this x plus 3 whole square. So the equation would look like x plus 4, 15x power 3, then 35x power 2, then 21x minus 4. And after this, we have ax square, x plus 3 whole square, and then bx, x plus 3 whole square, and then c, x plus 3 whole square. Just for d, it will not be multiplied with x plus 3 whole square because it eventually cancels out, right? Because with d, it is already divided with x plus 3 whole square, and if you further multiplied it with x plus 3 whole square, obviously they will cancel each other out. So I'm not going to write this down. I'm just going to write d over here. Like you only have a d. Other than that, nothing will be multiplied with d. So I can clearly understand d is 4, right? Because d is a constant, 4 is a constant. So first thing I can understand from this equation that d is 4. But I have to further simplify the equation actually to find out the value for a, b, and c. X plus 3 whole square is actually x square plus how much? 6x plus 9, right? So I'll just write this down over here that x plus 3 whole square is actually x square plus 6x plus 9. So if I'm going to insert the equation ax square, this is actually x square plus 6x plus 9. So it will be ax power 4. Then ax square with 6x is going to be 6ax power 3 square and power 1, 3. And then again 9ax square. Further again, you have to break down this bx with x plus 3 whole square. Bx multiplied with x square gives you, it gives you bx power 3. Bx with 6x is again 6bx square. Bx with 9 is just 9bx, right? So you get this equation for bx with x plus 3 whole square. Similarly, break down this x plus 3 whole square with c. So you get cx square plus 6cx plus 9c plus d, and all of this is equivalent to your 2x power 4, 15x power 3, 35x power 2, and 21x minus 4. I'm going to further simplify this, that over here how many x power 4 do you have? We have a x power 4, x power 3 and x power 3, so we can write this as 6a plus b x power 3, right? So this is done, this is done, this is done. X power 2 is 9x square, 6bx square, cx square. So we have 9a, 6b, and plus c x square. All of this were x square. So this is also done, 1 minute. And after that, only for x, we have 9bx plus 9cx, right? So 9b and 6c. So you can again write 9b plus 6c x, and finally for the constant, now you can see that you have actually two constant. So you can write this as 9c plus d, and this is all equals to your 2x power 4 plus 15x power 3, 35x square, 21x minus 4, right? So if I write this equation, 2 over here is equals to a, 15 is equals to, if I use different inks, 15 is equals to 6a plus b. Then again your 35 is equals to 9a 6b plus c. And your final answer is 21 is 9b plus 6c. So this is not the final one. Minus 4 is equals to 9c plus d, right? That means I can obviously understand. I have to start with comparing. So I'm going to start with comparing A. We get the value for A as 2, yellow, yellow if you focus. So comparing, you get the value for A. When over here, I'm going to write that what I'm comparing over here, the coefficient of x power 4, right? And that leaves you with A is equals to 2. Then again, coefficient of x power 3. That leaves you with 6a plus b equals to 15. 6a plus b equals to 15. I already know the value for a is 2 from this previous x power 4 comparison. So we get b 15, 6, 2, that's 12. So we get the value for b as 3. Again, comparing x power 2. So we get 9a. Let's not compare x power 2 because we have a and b over here. We can just directly compare x over here, purple one. So we get 9b plus 6c equals to 21. So we get the value for c as 21 minus 9. B was 3 actually, and divided by 6. So you get, I think it was 27, right? 21 minus 27 divided by 6. That leaves you with minus 1. So the value for your c is minus 1. If the value for your c is minus 1, then you go for the constant value. Constant, you get 9c plus d is minus 4. So 9c plus d is minus 4. So you again get the value for d as minus 4 minus 9 minus 1, right? So you basically have minus 9 plus minus 4 plus 9, which is 5. So you get the value for a, b, c, and d. Finally, you have to write down the equation in the format. The format was ax squared. So you get 1 minute. The equation was written as fx, right? So you can write your final answer as f of x as 2x squared plus 3x minus 1 plus 5 divided by x plus 3 whole square, right? So this is your final answer. All these things for your part A. Tajdeed, is this clear?
Yes, miss. Yet it is too lengthy.
It is lengthy, and even if you don't want to use this comparison method, you want to use that. Wait 1 minute.
Miss, just to make sure, for the thing you have done, the, in the question they told you like that equation was equivalent to this
Hmm.
general equation given. So
Mm-hmm.
we can like equal these two sides like the given equation and the general equation they given and they gave like
Mm-hmm.
we used to compare it, right? After
Mm-hmm.
we break down the equation that was f of x given, and then
Hmm.
after breaking down it to like the general equation, then we compared. So if
Hmm.
we don't do like this, just we can equal it like both that equation and that equation, and we can solve the two equation and link for the a, b, and c.
I don't understand the last part. I mean, equal it means, I mean, we are considering that this equation is equals to this equation, right?
Oh,
Comparing is
okay.
also the same format. Like we consider that this equation can be written in this format, so they are both equals to each other, right?
Oh,
We're
okay,
starting with
okay.
the same equation. They are equals to each other, and after that we simplify the right hand side to the left hand side.
Okay,
The
miss.
other format that you could have used here is long division, right? But long division will also be a lengthy process because you can understand there's x power 4 here, right? We always do long division for x power 3, so this is x power 4. So you can do long division over here, but in long division, you will not get your answer entirely. The remainder is not going to be 0. The remainder is going to be 5. The remainder is going to be d, right? Because that's why it is written in this format. If you do long division, the long division process is supposed to look like this. X power 4 plus 15, x power 3, then I think it was 35x squared, and then 21x minus 4. This will be divided with your, I cannot like divide this with just x minus x plus 3. I have to divide this with x squared plus 9x plus 6. That was the x, sorry, I made a mistake. This was actually 6x plus 9, right? This was your x plus 3 whole square. When you divide these things in the numerator, I'm supposed to get your, what was that thing? I'm supposed to get your 2x square plus 3x minus 1. And if you carry on with the long division in the denominator, you're supposed to be left with 5. Okay. And this supposed to be is, and then in this case, I'm going to write this down as um that okay, your x power 4 plus 15 x power 3, then 35 x square, 21 x minus 4 can also be written as 2x square plus 3x minus 1 plus 5 divided by, this is your dividend. Dividend was actually x square plus 6x plus 9, and this can again be written as 2x power 3x minus 1 plus 5 x plus 3 whole square, right? So this is another format that you could have used, but this will also be lengthy because it's a very large polynomial to long divide, to divide over here. Is this clear, Tashdeed?
Yes, yes.
This is your method 2 you can consider. Okay, so we're done with part A. For part B, we just have to do simple integration. So if we start with f of x, integration. For integration this time, I'm not going to use that 2x power 4 equation. I'm going to use the divided equation that I got in part 1. So over here, we got 2x squared plus 3x minus 1 plus 5, and then x plus 3 whole square. So if I do the long division on this, so we get basically x power 2 is going to be 3. So you get 2 by 3 x power 3, then 3 by 2 x square minus x. But for this one, actually, there's a problem. We have this x plus 2 whole square, right? For x plus 2 whole square, if I want to, like, even if I want to do, what was that? Integration. I'm supposed to consider this as actually 5x plus 3 power minus 2 dx. Okay, now again, if I add 1 with this, it's going to be minus 1. So you get basically minus 1. And then again, I mean, if you just focus on x plus 3 power minus 2, if you integrate that, you get minus 1 divided by minus 1. So eventually, now you have plus 5x plus 3 minus 1 with minus 1 plus c. If you simplify this, you get 2 by 3 x power 3. 3 by 2 x power 2 minus x. This minus 1 and plus 1 is just going to be minus 5. And also in this part is you have minus 1. So you should write this down in the denominator. X plus 3 plus c, right? And this is your final f of x integrated format. Other than this, you cannot, I mean, you don't have to write anything else. Is this clear, Tajdeep? Any problems so far?
No, miss.
Okay. I'm going to solve one other maths over here, okay? So that, we can solve other half of this part of the equations in the next part, in the next class. So we have to prove this cot square x minus tan square x is 4 cot 2x and cosec 2x. Okay. Since we have tan square x and cot square x, that there was one equation which was, I think, related to your cot square x, cosec x, tan x, sec x, but this will not be handy over here. Over here, we have cot square x and tan square x. So for part A, I'm going to write cot square x and tan square x. We have cot x and cosec x. Cot x means 1 over tan, which is actually cos by sine, and sine is 1 over, I mean, cosec is 1 over sine, right? So if I break down cot, I can break down cot as what? I can break down cot as cos square x divided by sine square x. And I can also break down tan as sine square x and cos square x. If I do the LCM, I'm going to get cos square x sine square x and sine power 4x actually, right? Yeah, sine power 4x. And in the denominator, I'm going to get sine square x cos square x. Just 1 minute. Okay, sorry. So for this part, we have cos square x sine square x minus sine power 4 divided by cos square x and sine square x, right? Um, if I now split this down, we are going to have 1 minus sine power 4 or sine square x cos square x. That doesn't give you anything. I'm supposed to work with 2 cos x and like cosec 2x and cot 2x. Cos by sine, sine by cos. So I'm going to get, oh wait, sorry, made a mistake, I think. We're supposed to have cos power 4 here also, right? Because cos square x sine x was actually multiplied with each other. So cos square x and cos x was multiplied with each other. So we have cos power 4x, sine power 4x, divided by sine square x and cos square x. I can now break this down. I can consider this as cos x square power 2 and then again this square power 2. So if I want to break this, I can break this in the format of a square minus b square format. So which is going to be cos square x minus sine square x and then again cos square x plus sine square x, right? And then divided by sine square x cos square x. This is in the denominator. But other than this, we have sine square x cos square x, sine square x plus cos square x. This can be written as 1, right? This entire thing becomes 1. So again, in the next line, we can write, okay, cos square x and sine square x. This was all multiplied with 1. So there's no point of writing that. This is again further divided with your sine square x and cos square x. If I now want to break this down fraction, okay, you get 1, I mean cos square x, sine square x, cos square x, you get 1 by sine square x, that restores your cosec 2x, but on the other hand, it will restore your 1 over cos is actually sec square x. Okay, that doesn't give you your sine, like cot 2x and cosec 2x. But for cosec x, I mean, as we are trying to find out cot x and cot 2x and cosec 2x, I can consider like, breaking this down in the format of cos 2x. There was another formula for cos 2x. It was cos 2x is equals to 2 cos square x minus 1. Okay, 2 cos square x minus 1. If I break down this sine square x into sine square x into 1 minus cos square x, I'm going to get cos square x, like 2 cos square x minus 1, right? Yeah, this is how I'm supposed to write this, break this down. I'm going to consider cos square x. I'm going to break down this sine square x as 1, sorry, 1 minus cos square x divided by your sine square x cos square x. I can also break down in the denominator. Like you have sine square x and cos square x, right? Sine square x and cos square x. Wait, can I break this down? Uh, 1 minute. I think I can. I mean, over here, I can also consider the other equation over here. The other value for your cos 2x was actually 1 minus 2 sine square x. So over here, if I break this down, sine square x, 1 minus sine square x, no, that will multiply this as 1 minus sine power 4x. Sine power 4x doesn't have any value, no. Okay, let's just focus on the numerator first. For the numerator, now we get cos x is 2 cos square x minus 1 divided by sine square x and cos square x. 2 cos square x minus 1 is going to be your cos 2x. And in the denominator, you have this your, sine square x and cos x. I can actually break down this. Over here, if you think, you have this format, right? You have another format actually. The other format was sine 2x is equals to sine 2 sine square x and cos square x, right? So if this is the case, I have to somehow introduce this over here. So it was actually normal sine x and cos x, not square. Sine x and cos x. Over here, I have to introduce this into this equation. For sine x, I can consider this as mm, I can consider this as sine square x and cos square x it was. I can consider this as half sine x and cos x. You have to understand that why I'm going to multiply half with this so that it balances up. That inside the equation you're supposed to have 2, but I don't actually have any 2, so I'm going to balance that out with half. So half and 2 cancels each other out. So eventually you will have this, sine x and cos x. So I can now break this down as half multiplied with 2 sine x cos x and everything with a whole square, right? That balances your value for not exactly half. I mean, over here, if you consider this 2 sine x cos x whole square, wait 1 minute, let me just write this down over here. In your equation, you have 2 sine x cos x, right? And that was equals to sine 2x. But if we use half sine 2x, so then you will have just half. I mean, this 2 will has to be multiplied with half. They will cancel each other out. You have sine x and cos x, and since you have sine square and cos square, so I again have to introduce square on this. So you basically have the same equation now, right? Sine square x cos square x is equals to half sine 2x whole square. So now over here I can directly write that in this case I have 1 by 2 sine 2x whole square. I can break down this 1 by 2, or I can just write this 1 by 2 whole square separately. So you basically have cos 2x 1 by 4 and then sine 2x sine 2x. I can write this 4 with the numerator as it was in the as it was as a fraction, right? So we basically have 4 cos 2x divided by sine 2x sine 2x. There's a reason for writing sine 2x separately, because we have sine 2x whole square. Sine 2x whole square means we have 2 sine 2x multiplied with each other. I'm going to break down this as cos 2x divided by sine 2x, and then again multiply this with your 1 divided by sine 2x. So eventually have 4, this is what? Cos by sine is your cot. So you get cot 2x, and then 1 by sine is your cosec 2x, right? So this is all the working you need to do just for the derivation. And these are the basic equations which were used over here in this maths, right? Basic formulas, trigonometric equations that we are using in this derivation. Is this clear, Tashdid? Any problem from question 5a? Tashdid, any problem from question 5a?
No, miss. But there are
Okay.
lots of formula to be applied.
No, not lots of formula to be applied. Only 2 formulas to be applied. I mean, this is the basic equation we always do, right? Cos square plus sine square equals to 1. This is a basic equation. Other than that, only for over here for cos 2x and sine 2x. Other than these equations, I didn't use any other equation. Only 2 formulas.
No, that's not the thing. I
Hmm.
was thinking, like you are comparing the which formula to be chosen. You know, you just thought the first formula you think that is not the applicable one, then you thought of another one. That's the thing
Oh,
I was
ha.
telling.
No. Yes, you have to obviously consider this type of workings. I mean, you have to work with the different formulas for derivations.
Like
Okay, so over
lots of
here,
formulas to be applied. That's what I
these are
told.
4-mark questions. They're giving you 4 marks, so trigonometrics identities are going to be a little lengthy. Okay, now if you move on to part B, within the range of negative 90 to 90, we have to solve this equation. 4 cot 2 theta cosec 2 theta is tan squared theta. Okay, I have to first simplify this equation. 4 cot 2 theta cosec 2 theta equals to 2 tan squared theta, right? Over here, if I Remember that this equation could also be written as cot square theta minus tan square theta something, right? We started the equation, right? Cot square x, tan square x. So that means I can understand the left side of this equation can also be written as 4 cot square theta minus tan square theta and then 2 tan square theta, right? I'm basically considering this equation separately. Cot 2 theta, cosec 2 theta could be written as cot square theta and tan square theta. If you take this 2 to the right hand side, it will multiply with 2. I mean, if you take this 4 to the right hand side, it will be divided with 2 and eventually you get half. So you get cot square theta, tan square theta, and then half tan theta. So if you take this tan square theta, it's a tan square, take this tan square theta to the right hand side, half plus 1 will be 3.5. So you have cot square theta and then 1.5, actually not 3.5, 1.5 tan square theta. So cot square theta and tan square theta, cot square is I think what? 1 by 4, right? So 1 by tan. So it is 1 by tan square theta and you get 3 by 2 tan square theta. So if you take all the tan square thetas together, you get 1, 3 by 2 tan power 4 theta. And now if you just take this fraction to the right hand side, you basically have tan power 4 theta 2 by 3. And then again, if you write theta, I mean, it will be just tan theta. You basically have 2 by 3 power 4. And then finally, you can write theta as tan inverse power 4 2 by 3, right? This is your calculated value. If you simplify this, obviously carry out your calculation in radian, you get 1 minute 4, then 2 by 3. The first value that you get is 0.745 734, actually 735. Answer should be 2 decimal place, so you get 0.73. So your first calculated value is 0.73, which is less than 90, I think. One minute, let me check. Pi by 2 is 1.57, so this is less than 90. We can accept it, but we also have to accept the positive and negative values, right? So if you consider the positive values separately, your tan theta, I mean just theta is 0.73. Your second value has to be calculated here. That is going to be, it is generally 180 plus first value, which is your pi plus first value. If you add pi plus 0.73, this will be greater than your range, right? We can clearly understand. So we are not going to accept that. Obviously, after this value, third value, fourth value, they will also be outside your range. So you're not going to continue with that. But if we continue with the negative part, because over here the range was also given in the negative range or negative value for x. So that means the first value over here is also 0.73. But for your second value, just 1 minute, please. For your second value, it's going to be minus pi plus 0.73 because now your data is in the negative range. So your pi also becomes negative. So if you calculate this, minus pi, so minus pi 0.73, that is now negative 2.41, right? We're supposed to calculate this. I know this also doesn't fall under my range because my range was plus minus 1.57. This is also greater than my range. So now I'm going to accept this also. So the very basic answer is this, that we're going to have this plus value, and again for the negative coordinate, we're going to have the same value in the negative. I mean, same value over here with this just 0.73, right? Wait 1 minute. Since we have 1 minute, power 4 2 by 3, 0.91. I mean, over here, you're supposed to think of this. Wait, sorry, made a mistake. It's supposed to be half over here. So it was 1 by 2. But all this time, it was actually half. So you're supposed to get just 2 here, right? 1 minute. 2 by 4 is half. This is half. Oh, no, made a mistake. This is 3. No, 1 minute. It was 4 cot 2x and cosec 2x. Yeah, actually made a mistake. In this entire derivation, we got the total answer as 4 cot 2x and cosec 2x. So we're not supposed to write multiply 4 with there. It was entirely your cosec square theta and cot square theta and tan square theta. In that case, if you take this to the other hand side, like this one and this 2 tan square theta, they're going to add it together and we're supposed to get 3 over here. So all this time you had 3 and then you have 3 here, so you're supposed to get 1 over 3. Yeah, sorry, I made a mistake. This was 1 over 3. And then again, if you write this, if you split this down, 1 over 3, this one actually gives you plus minus value, because after coming out from square or power 4 or even number of roots, you always get a plus value and minus value. So you get tan square, this is positive, and then again you're supposed to get tan square and tan inverse root 4 1 over 3 negative value. So you're supposed to calculate this 2 times. It will be 1 over 3 power 4 positive, that is 0.65 actually. This is 0.65, and you have to carry on with the same fraction with the negative value, which is again negative 0.65. That means you have to carry out your positive value, negative value for both the data. So you get 65 here, 65, positive 65, and then again over here 65. And actually both cases you eventually end up getting greater values. Actually for positive 65, if you focus, you're eventually going to end up with greater values, I think. Yeah, this one is also going to be greater than negative 2.41, so it is also outside your range. We cannot accept this one. And again for your second value of x, which was for tan inverse negative root 4 1 by 3, 0.65 negative, for that if you want to find out in the positive range, but theta is now negative 0.65. Your second value is going to be pi minus 0.65. This also doesn't fall under my range. And, or 1 minute, let me check. 0.65. Yeah, this is 2.49, greater than my range. And again, if you do this calculation for my negative range, for the negative value of my theta, which was 0.65, this is going to be minus pi minus 0.65. This is also outside my range. So I can understand that for both the value of x, I cannot get any second value either from the positive side or from the negative side. So we're going to get, we're going to finally write down the answer as 0.65 plus minus, right? Because these are the only solution. Other than this, we're not accepting any other solutions here. But even if we in this maths I didn't got any solution, but in some other maths I might get some other solutions. So we have to always calculate this, the second value and third value in the positive and second and the negative range. We're accepting the negative range here because it was stated in the question from negative 90 to positive 90. That's why we have to accept the negative range separately again. Is this clear, Tajdeed? Any problems so far from question 5?
No, yes.
Okay, then
This call is now being recorded.
okay, in the last class we completed up to question 5 from Jan 23 P3, right? We're going to move forward to question 6. Question 6 about your functions, Tajdeed. These questions you struggle a little, but they're not that much confusing actually. I mean, over here, we can see that the graph intersects on the x-axis at 2 points, P and Q, and on the y-axis with P, and the minimum point here is S, right? We're supposed to find out the coordinates for this 4 different points respectively. So first part is that they're focusing on point P. Now, point P was at y-axis, and at y-axis, x is always 0. So we can write that for part A1, for point P, is on y-axis. So we can write at this point x is always equals to 0. If x is 0, then in your equation we had the equation as 3x minus 5a modulus minus 2a, right? So this 3x over here will be entirely 0, right? This 3x is not fine. I mean, we're not concerned about that. So this 3 multiplied with 0 is entirely 0, and this 5a minus 2a. Minus 5 absolute function means that we have 5a will be positive now, right? Anything inside those absolute values will always be positive. So 5 minus 2 is going to be 3a. So this is the value for your y. If the value for y is 3a, then I just have to, we got the coordinate for p. Final coordinate for p is going to be 0, 3a, right? Just 1 minute. Okay, so we are done with part 1. For part 2, they're asking that find the coordinates of Q and R. Right, for Q and R, we know they're on the x-axis. So for them, the y value will be 0. So for part 2, Q and R are on the x-axis. So there, the value for y is 0. If the value for y is 0 here, then I can say that 3x minus 5a, absolute value 2a, 0, right? We're going to take this minus 2a to the right hand side, so it will be 3x minus 5a, absolute value equals to 2a. Now this absolute function means that either the expression that you have inside this absolute value, it could be either positive or negative. So we'll do this calculation one time, considering that 3x minus 5 is a positive value, that is equals to 2a. If you solve this, you get 3x, this is 5a. You have 5 plus 2 is going to be 7a. So you get the value for x as 7 over 3a, right? So this is one value for x. 7 over 3 is how much? 1 minute. 7 over 3 is 2.33 in decimals. And we have to do the same calculation. I mean, not same calculation, same equation with a negative value now. So this negative value makes this minus 3x. This was actually plus 5. If you take this to the right hand side, it will be 2 minus 5. So again, you have minus 3a. So you get the value for your x as just a, right? So this is 1 and 2.33. I can understand this is the coordinate of your r and this is the coordinate of your q, because in your graph also q comes before r. So you get q as a 0 and r as 7 by 3a 0, right? So these are the coordinates for part 1 and 2. Up to part 1 and 2, it was all easy. For part 3, it's a little bit tricky.
Miss,
Mm-hmm.
just one thing. Can you again please tell me that the absolute value thing you just told?
For absolute value, like whenever we are using an absolute value, for example, in this case also, we had a 5a with absolute value, right? Anything inside the bracket, inside this absolute value, if it's negative, they will also filter out, they will always filter out as a positive answer, right? But problem is, this is a fixed number kind of thing, right? We only have minus 5 here. So I can understand that, okay, after the absolute value function, minus 5 will become positive 5. But problem is, in this equation, in this part, I was working with an entire expression, right? We have 3x minus 5a. We have two variables here. Maybe a is a constant, but x is a variable here, right? So we do not exactly know that if this 3x plus 5a minus 5a is actually a positive value or a negative value. I mean, yes, we understand that after coming out from this absolute value, it will be always positive, but we do not know that in general if it was a positive or negative value. So since whenever I'm working with an expression inside absolute value, I always have to take one positive version of that expression and one negative version of the expression. Is this clear?
So as it filters out as a positive value, so
No,
why we are like working with the
no,
negative one?
no, I'm not using the absolute value functions, right? In this case, you can see that I'm not carrying out with the absolute function. From the absolute function, if I was working with, I'll always have to work with that, like, zero, positive functions. But over here, I'm considering that without the absolute function, right? If you consider that there was no absolute function, then this entire expression, it could be either positive or negative. With the absolute function, it is always positive. But without the absolute function, the original equation could be positive or negative. That's why we have to solve this with positive and negative version. In this solutions, I'm not using absolute functions, as you can see. I eliminated that. That's why I'm using the two possibilities of the function, or two possibilities of this expression, one with positive, one with negative.
Oh,
Is it clear?
yes. That means whenever the expression is inside the
Mhm.
absolute value, we will eliminate that absolute value thing,
Hmm.
and we will work
We
with the positive and the negative value.
separately, yes. Okay, then after this, we're trying to find out the coordinate of point S, right? For point S is the minimum point on this graph, right? So one thing to understand that if this is the minimum point, if you can look over this equation, we have y 3x minus 5a minus 2, right? So this is the minimum point that the graph can have. And exactly at this minimum point, the absolute value, like over here for this minimum point, you can actually get the value for your entire function of your absolute value 3x minus 5a entirely as 0. Like this absolute value function, the minimum value it can get, like we already understand the absolute value can never be less than 0, right? It can never be negative. But the minimum value that this entire absolute function can have is 0. So if the entire absolute function at this point is 0, so I can get the value for x as 5 by 3a, right? If your value for x is 5 by 3a, then we can also calculate this for the value for y. Value for y is going to be y 3 5 by 3 minus 5a absolute 2a, right? So this one actually restores you what? This is actually 5 minus 5a. Wait 1 minute. Made a mistake. This is an a here also, right? So we have this and this cancels out. So we have 5a minus 5a minus 2a, right? So obviously this is entirely 0. So you get the value for y as negative 2a. So finally you get the coordinate of s as 5 over 3a and minus 2a. So one thing to understand that whenever you're working with this type of minimum point or this absolute function graphs with this type of vertex, the minimum value that this absolute function can be is always equals to 0. So using this basic, we use the value for your x. We calculated the value for your x. And if x is this much, insert that into the equation to get the value for your y coordinate. Is this clear, Rajdeep? Any problem from part 3?
No, it's just one thing. When you found the x value, where is that minus 2a?
Oh no, because minus 2a is outside the function, right? We're only focused on whenever your graph is at this top vertex or minimum vertex, right? The minimum value is this one. For this minimum value, this entire expression can be equals to 0. This is outside the expression. right?
Oh,
For this
okay.
for this vertex, you have to think that this is the minimum value for your absolute value, for your absolute function, right? If you carry on with this, they will, like, your graph will, this portion of the graph was actually in this section, right? Your graph was supposed to intersect with the minus 2a, but it is not intersecting with minus 2a because I did the absolute function, right? So we are only focusing on the absolute function of this time, because from this point the graph kind of gets bended upwards, right? It was originally supposed to travel in this straight line downward, but from this point the graph becomes an absolute value. So the minimum value that absolute expression can have is 0. But obviously this is the minimum value. The maximum that it can get is all the positive numbers and can never be negative. So that's why the minimum value for this entire absolute function is 0. So using that you can solve the equation. Is this clear, Tashdeep?
Okay, miss.
Okay, so if I just take this to your part C, after this, they're now asking to solve this equation, right? So we have 3x minus 5a, 2a, x minus 2a. Okay. Values of x. So that means we're supposed to get multiple values of x. So if I take, I mean, again, over here in this case, absolute functions I'm working with, right? I do not know if the absolute functions were always like this, right? I do not know exactly if the absolute functions were always positive or always negative. So that means this time also I have to work with two variations, one with positive variation and the other with negative variation. So, and again, I have to consider the positive variation and negative variation for both the absolute functions. So if I take minus 3x minus 5a minus 2a, and then x minus 2a negative, and then again I'll have to take the same equation as 3x minus 5a minus 2a x minus 2a, right? So we can write this as minus 3x plus 15a minus 2a minus x plus 2a, and then take all the values of x's together. So you have, wait 1 minute, I'm making a mistake. Minus 3 plus 15 minus 2 minus 6 plus 2, right? So this 2, oh no, they will not cancel at each other out. So you have, I mean, 2 and 2 will become 4. 15 minus 4 is just 11a. And this you take to the right hand side, you have like 2x. So you get the value for x as 11 by 2a. One value is this. Oh, wait, I'm not supposed to get 15, right? It's supposed to be only 5, right? So you get, sorry, this is actually 1a. So you get half a from this equation. And from the next equation, again, you have 3x minus 5a minus 2a, x minus 2a. This time 2a cancels out and you get 2x equals to 5a. So eventually you have x equals to 5 over 2a. Right, so these are the two values of x in terms of a. We're done with this. Other than this, nothing else has to be calculated from this question 6. Is this clear, Tashdeep? Any problem from question 6?
No, miss.
Okay, then we are going to quickly move on to question 7. Just 1 minute. Okay, in question 7, this is about differentiations, right? Now, this one is given as y is equals to 10, 3 y minus pi by 6, and we have to differentiate this equation in this format where a and b are constants to be found. Okay, so if I write this first, that x equals to 3 tan y plus pi by 6, that means it will be x by 3 pi by 6, right? So this is another expression that we have to use in the previous cases, because I always have to, like, somehow extract x into the equation. So I'll have to use this. And now if we start with the equation, that, okay, the equation was y is equals to 3 tan y minus pi by 6. And if I start with the differentiation, the dx with dy, right? For this dx with dy, tan, if you differentiate tan, you always end up getting sec square, right? So I'm going to get 3 sec square y pi by 6. And after this, again, I can break down this sec square as how much? I can break down this sec square as 1 plus tan square. So we can write, I'll separately write the 3, and we can write 1 plus tan square with this value y minus pi by 6. And then again, after this, for this value, if we focus on, we basically have 3 plus 3 multiplied, not exactly, wait 1 minute, I'll just write this separately. 1 plus tan y minus pi by 6. I mean, what does this tan square means? This is just tan y minus pi by 6 whole square, right? And if you remember, tan y minus pi by 6 is x by 3. So instead of writing this over and over again, I can, instead of this position, I can now write x by 3 whole square root, right? This is what I can actually write. And if I simplify it further, I get 3 plus 3x square by 9. If you again simplify this, how much I'm going to get? X square by 3 is, I think, 1 by 3, right? Yeah. So over here, I'm going to get 1 by 3. If you do the LCM for this, you get 9 plus x square by 3. And you have to understand that this is the expression that we're getting for dx dy, right? All this time, I was getting this for dx dy, but in your question, they were asking for dy dx. So I just have to invert this, right? Finally, I don't have to do anything else. We simplified the equation entirely. I'm just going to invert this and also write this like this, x square plus 9. So if I want to find out dy by dx, I just have to write 1 dy dx. So you get 3 over x square plus 9. That means this was A and this was B. So A here is 3 and B here is 9. If I zoom out, you can now see the entire maths over here. But you can consider, this equation is equation 1, this is equation 2, and you can add this statement over here that's substituting 1 into 2. It was not quite necessary, but you can obviously include that. Right, this is all the things you need to do for your part A calculation. Tashdeep, is this clear? Any problem from 7A?
No, miss.
Okay, then we'll quickly move on to question 7B. For B, it says that, so 7B, it says that point P with x coordinate this lies on the curve, and given that the tangent to C at point P crosses the x-axis at point Q, so you need to find out the x coordinate of Q. So we already can understand that in order to find out the x coordinate, I need to work with the tangent. But for tangent, we need to find out the y coordinate of P also. So x coordinate of P is pi by 3. So in that case, y coordinate of P I'll have to calculate. So if you have x is equals to 3 tan y minus pi by 6. From there, I have to extract the value for x. So, wait, is the x coordinate 3? No, the y coordinate, sorry, y coordinate was 3, yeah, sorry. So if I write that, okay, the value for y is pi by 3, in that case, I get the x coordinate as 3 tan pi by 3 minus pi by 6, right? So I'm going to write 1 by 3, 1 by 6, that leaves you with 1 by 6 again. So you again have 3 tan pi by 6. So you just have to, do your radian, do your maths in radian mode. So you have 3 tan pi by 6, and that is equals to root 3. Okay. And now you can write that, okay, the coordinate of point P is actually root 3 and pi by 3. So after this, what do we have? Part B. So x coordinate is this, I mean, x coordinate is this, y coordinate is this. Now you just have to like what, factorize, find out the gradient of the curve or of the tangent at point P. Both gradient and curve, I mean, tangent and curve will have the same gradient because they are parallel to each other. So we can write that, okay, dy by dx, if that was your 3 x square plus 9, so it will be the root 3 square plus 9. So from there you can write 3 root 3 square plus 9, which is going to be 1 by 4. Again, this is the gradient of curve C, by the way. And we have to now write that a curve and tangent are parallel to each other. So from there, gradient of your tangent is going to be 1 by 4 again. So finally, your equation for your tangent is going to be y minus your pi by 3, that was your y coordinate, and 1 by 4 x minus root 3. So you basically have y 1 by 4x, and this is going to be root 3 by 4 plus pi by 3, right? So finally you can write the equation as 1 by 4x, and this is going to be, root 3 by 4 plus 1 by 3. You get this as an entire expression value, like 4 minus 2 root 3 type of value. So I can write this as 4 minus 3 root 3 divided by 12 pi. Okay, this is the equation. Now again, I know that at point Q was also a part of this tangent, and this tangent will intersect with the x-axis. So we understand that over here, Q was on x-axis. So there the value for your y was entirely 0. And in that case, we can write 1 by 4x, 4 minus 3 root 3 by 12 pi equals to 0. So you can just write this as 4 minus 3 root 3 by 12 pi. Right, if you take this to the right hand side, it will be positive, and this will be multiplied with this, right? So this will be multiplied with 4, so this and this cancels out, leaving with 3 in the denominator. So now you have, wait. Yeah, you have the same equation, 4 minus 3 root 3 divided by 3 pi, right? You can simplify this equation by dividing these two factors in the numerator separately, but that will not change anything. So you can just directly write, okay, then Q is 4 minus 3 root 3 divided by 3 pi and 0, right? This is your final coordinate for your point Q. And this is all the working you need to do. Quite easy, but very lengthy, right? You have to do a lot of working in order to get to the coordinate of point Q. Is this clear, Tashni? Any problem from question 7?
No, miss.
Okay, then if you move on to question 8. Question 8 is a small question, but big marks. 2 cos x minus sin x whole square, and then you have to do integration. First, I will break down that whole square, right? So we have 4 cos square x minus 4 cos x sin x and plus sine square x, right? Then we'll move forward. That 4 cos x sin x, right? If you focus on that, I'll write this as actually sin x before cos x. Sin x, cos x. For this one, if I focus, I'm going to use 3 cos x, like cos square x here, and 1 cos square x with this sin square x. I'm going to write it down separately. So I'm going to focus on 4 cos x sin x. So 1 minute, I'll just write this down over here. That's sine square x. This is one part. This part is always going to give you the value for 1, right? And for your 4 sin x cos x, I can write 2 sine x cos x, right? Because we have a value for this 2 sine x cos x is actually sine 2x. That's why I'm going to use that value. So we get 3 cos square x. This is going to be 1 entirely, and this is going to be 2 sine 2x dx. And again, after this, we have 3 cos square x to work with, right? Cos square x, I can break down cos square x as cos 2x value. If you remember one equation that in the previous part also we used cos 2x is 2 cos square x minus 1, right? So if I want to express this equation as cos square x, I can express this as cos 2x plus 1 divided by 2. So I'm going to use this value. We have 3 cos square x. Instead of using 3 cos square x, I'm now going to use this as your what value? Three cos 2x plus 1 divided by 2. So 3 cos 2x. I mean, this entire thing is actually multiplied with 1 plus 1 divided by 2 multiplied with 3. And then plus 1 minus 2 sine 2x. For sine 2x, if I want to explain, sine 2x is actually what value? Sine 2x is your sine x, cos x, and cos x, sine x. Sine x, yeah, x plus x is sine 2x, sine x plus sine x cos x, and cos x sine x. But that again goes back to your original 2 sine x cos x value. It doesn't restore anything, but I can actually differentiate this entirely. Sine 2x differentiation, it's possible. So I can differentiate it, so integrated sine 2x directly, which is going to be cos 2x, negative cos 2x, half negative cos 2x. I'm just going to keep it like this. 2 sine 2x, because we still have to do some simplification for the first term in this equation. So we get 3, we basically get 3 by 2 cos 2x, and then 3 by 2 cos 2x, 3 by 2 separately, plus 1 is just going to be 5 by 2, and then 2 sine 2x, and now we can differentiate the equations entirely. So for the differentiation, we can work with, this is half, this is 2, right? It will be half 3 by 2 sine 2x. This is going to be 5 by 2x, and this is going to be half 2 sine, so it's 2 cos 2x. You have to understand that integrating sine gives you always negative cos, it will be positive now. And obviously with this c, because this was not a integration with boundary. So you finally get 3 by 4 sine 2x, and then cos 2x, 5 by 2 x plus c, right? So this is your final answer, that 3 by 2 sine 2x cos 2x plus 5 by 3x plus c. And that is your final integration part. Tashdid, is there any problem from question 8?
No, miss.
Okay, then we're done with this question also. I'll quickly move on to question 9. This is about numerical methods. First part is not about numerical method. First part is about simple differentiation. X plus 3 e power x square whole square, right? So we have part A as 3 plus 4
Miss,
e
can you
power.
zoom back?
Sorry?
Can you zoom out?
Oh, can I zoom out 1 minute?
Yeah.
Okay.
2, 3, 5, 6, 7, 8, 9, 10, 11. Oma, 11 marks of this numerical method.
But up to part D, it was not about numerical maths. That was about integration and all. Integration and exponential. Only this last part. Part E was about numerical methods. Other than that, everything is just differentiation and integration. So we have like differentiation and exponential. 4e x power 2, 4e x square, and then everything under the square root. Square root means that over here everything is under the power of half, right? This is equals to y. That means I have to do chain rule over here. dy by dx is going to be half 3 plus 4e power x square, with negative half this time. Half minus 1 is going to be negative half, and inside the brackets, if you differentiate, 3 will be vanished. I mean, we have 4e power x square, right? So that will be differentiated as 4, when just e power x actually can be differentiated. For e power x, you'll get x e power x square. So that will be eventually 4x e power x square. So eventually you can write this 4 and 2 cancels out, leaving you with like what value? Oh, wait, sorry, made a mistake. We're supposed to get, like, since we have 2x, so it will be actually multiplied with 2x e power x square. So eventually you have this and, I mean, not this and this cancels out, leaving you with 4x e power x square, and then 3 plus 4 e power x square with the power of half, right? So this is the rough expression that you get for your dy by dx. Part A is done. For part B, they are saying that point P with x coordinate alpha lies on C, and given the tangent to point P passes through the origin, that means the coordinate 0, 0, as shown in figure 3. So show that x is equals to A as a solution of this equation. Okay, if x is equals to A is going to be a solution for this equation, I have to work with the, like, your differentiated equation this time. Yeah, I have to work with the differentiated equation. Wait 1 minute. Tangent passes through origin, right? X is equals to A is a solution for this equation. If x is equals to A, then y is equals to, show that x is equals to is a solution of this equation. Tangent to C at point P passes through the origin. Like on further level, you extend this, they will pass through the origin. This tangent passes through the origin. Oh, then this is in what format? This is exactly y is equals to x value, right? I mean, that's what's happening over here. Y is equals to x equation. This is the tangent for your graph now, which also passes through point P. And the x-coordinate of point P was given, and we're supposed to, like, find that if x equals to A is actually a solution of this equation. But to be honest, we cannot find out the value for x equals to A in this kind of pattern. What we have to calculate is that since y is equals to x, so I can write that, your part B, y is equals to x is the tangent, right? So I can write this, that 3 plus 4e x square under the square root, that is equals to x. So which means that over here, your 3 plus 4e power x square divided by x. Just 1 minute, Tashdeep. Sorry, as I was explaining here, so this is one of the equations that you can write, right? But it was also stated that this tangent is your, like, equals to your what value is equal to your so this equation is a tangent for the graph also, and this equation, if it's a tangent for the graph, that means the tangent's gradient and the graph's gradient are actually going to be equal to each other, right? Now this is also can be considered as the equation for a gradient of the tangent, because you're doing basically what, y divided by x, right? This could be considered as a gradient for tangent. And as we know, gradient for tangent and curve, they're always equals, right? Gradient for tangent and curve, they're always equals to each other. They're always same. So if this is the gradient for tangent, and dy by dx, that was 4x ex square, and then 3 plus 4x ex square to the power of negative half. This was the gradient for curve, right? If this is the case, then what? I can, like, consider them as equal, because their gradient of tangent and curve are always parallel to each other, and they have the same gradient. So I can write that curve parallel to tangent, so same gradient. If they have the same gradient, then now I get the expression 3 plus 4e x square divided by x with the power of half, and then again 4x ex square, 3 plus 4e x square with the power of negative half, right? I can see them as equal. Now if I just have to, like, simplify them. So if I simplify them, we get 3 minus plus 4e x square half. If I take this to the right hand side, we basically have 4 x square ex square divided by, this is actually a negative power, right? So obviously they belong to the denominator. 3 plus 4 ex square with half. If I take this to the right hand side, now we basically have 3x x square half. I mean, same thing multiplied with 2 will have a square value, right? And that is equals to your 4 x square ex square. So now I can write this entirely as, I mean, this half and 2 will cancel each other out. So basically I have 3 plus 4e x square and 4x square ex square. So we'll finally write this equation as 4x, so 4x square ex square 4x square minus 3 equals to 0, right? Now after this, we don't actually, like, have to do any calculations. You have proved this, that you got this from the equation from the gradient, or from the gradient of the tangent, and from the gradient of the curve. So obviously x equals to a would be a solution for this equation. Since we do not actually have the value for x equals to a, I won't be able to find out the, I won't be able to, like, prove this, that yes, x equals to a was actually a solution of that equation. We can no way prove that. But in this case, we can prove it, that okay, that if x equals to a was the point on, was a point on tangent, and if the gradient of the tangent and the gradient of your curve is equals, then means obviously x equals to a would have solved this equation. Is this clear? Any problem from this part B? Tashdeep, can you listen to me?
Yes, miss.
Okay.
Still confused for some reason. I
Why?
don't know.
Now,
Okay,
in
it's
most
okay.
of the cases, no, in most of the cases, what we generally do, for example, if the value for a was 5 here, okay, randomly giving, if they would say that, show that x equals to 5 is a solution of the equation, what would I do? I would just insert x equals to 5 in the equation, and that will give me the entire solution as 0 using the factor remainder theorem. And then I will prove that, okay, since f of 5 gives you 0, that means obviously, since your remainder turns out to be 0, that means obviously x equals to 5 was your solution. But problem over here, we don't have a magnitude. We don't have the value for a. A is also an alphabet. If I introduce another alphabet over here, what I'm going to get? 4a square ea square minus 4e a square minus 3, right? I won't be able to further simplify this or solve this. So how would I prove that, this x equals to a is a solution for this equation? So what I did is that I'm going to consider that, okay, this x equals to a was a point of P, right? And P was a tangent, like at point P, there was a tangent that was also touching the curve. So if the gradient of the tangent and the gradient of the curve, if I can somehow use them to extract this equation, that means obviously this will be the what? Intersecting equation, right? How did you got this? You got this from the gradient of the tangent, gradient of the curve by intersecting them together. So this is actually the intersection equation for tangent and curve. If this is the intersection equation of tangent of the curve and where they were intersecting at point P. So specifically to find the exponent of point P, we got the equation of that 4x square ex whole square 4x whole square minus 3, right? So from there, if the exponent of P is A, that means obviously A will be one of the solutions for this equation. Is this clear now, Tashdeed?
Oh, okay. We are using like this.
Yeah, we are using the intersection point because over here they were asking x equals to a is a solution for the equation, but a is an alphabet, so I won't be able to solve the equation with the value. So what we can see is that point P is the intersection of the curve and the tangent, right? So we already understand the tangent and the curve, they are parallel, so they will have the same gradient, but we created different equation, and we can again see from the graph over here from the tangent, this is actually y is equals to x line, right? So from there, we got the equation y is equals to x. Y value is this much. This divided by x gives you the value for the gradient of the tangent. So we got the gradient for the tangent, we got the gradient for the curve, and we know that point P was the intersection between tangent and curve. So we're going to use their gradient, consider them equals to each other, and solve them to find out the intersecting equation. Right? An intersecting point
Okay.
was point P.
Yes, that two matched. So
Right? So
therefore we can say this is that. Mm.
that x equals to a is going to solve this equation, is a solution for this equation.
Yes, I got it.
Right? Okay. No need to say that over here, only proving this is enough. Now they're saying that hence show that alpha lies within 1 and 2. That alpha lies within 1 and 2 means that you just have to insert x equals to 1, x equals to 2, and then find out the value, like what happens within this value. What we can understand that at x equals to a, this was the point P, right? And at point P, this was a tangent, right? This was the intersecting point for the tangent and also the kind of a turning point for this graph, as you can see. So that means at fx, I mean, where f is equals to a or x equals to a, at fa, the gradient was supposed to be 0 there, right? So this is what the main case was. We understand that for part C, when x equals to a, f of a was supposed to be 0 because we already used this idea, right? This is what gives you the value of your gradient at point P. But problem is that does it actually become 0 within the range of 1 and 2? We have to find out. So when we are using f equals to 1, so we have 4 1 square e 1 square 4e 1 square minus 3, and we are going to do the same calculation for your negative value also. If you calculate this data, you're going to get 1. And if you calculate this data, sorry, you're going to get minus 3. And if you calculate this data, you're going to get 652. What you can understand is that on this number line from 1 to 2, this is like 1 and this is like 2. At when the value for fx was 1, you got minus 3. And when the value for f2, you got 652. That means obviously somewhere near here, you got the value for f equals to a, that was 0, right? So that means obviously f lies in between the range of 1 and 2. So you have to say that f of x is a continuous value, and before f1 or before fa, we got a negative 3. After fa, we got a positive value. So obviously a must lie within the range of 1 and 2. Right, we can just write this down over here as a statement that A must lie and x equals to 2. Is this clear? Any problem from part C, Tajdeed? Tajdeed, any questions?
Just a moment, miss.
Okay, sure.
Okay, miss.
Okay, then if we move on to your next part, which is what part A, C is done, part D, right? They're saying that show that the equation part B can be written in this format, and part B can be written in this format. Okay, let's try. We are working with, and basically, now I'll have to factorize this to find out the value for your x actually. So for part D, they were asking that we have the equation 4x square ex square, and then again you have minus 4 e power x square minus 3 equals to 0, right? So if we start with the differentiation here, I can understand that in this case, your I mean, what? In this case, this is an x square and this is a constant actually, right? This entire thing is actually a constant. So if you take the minus as a common, this will be a plus. So we can write, we can just keep the x square over here. So we have 4x square, or I'll just write this as 4ex square, then x square, and equals to this. If you take this to the right hand side, it will be 4 e power x square plus 3, right? And now you're going to divide this x square, 4ex square plus 3 divided by 4ex square, and then again everything will be under the square root value because of this square. And when you break down the square, it will be either positive or negative, but we can take this, ex square, 1 minute, I don't know, 1 minute. Yeah, we have this ex square minus like e power minus x square with 3, not with 4. That means I am doing something over here. That something is that I'm going to take e x power 2 as a common factor. So we get 4 plus 3 e minus x square, and then we're going to divide this with 4 e x square, right? And everything over here will be under the square root. One thing to understand that ex square cancels out, and now we can write this separately as a power 4 3 e minus x square under the square root, and then again we're going to divide this as 4 square root, right? So which basically gives 4 square root is 2, so I can write this as half 4 plus 3 e minus x square, everything under the square root. So this is your value for x. Right, this is what they were asking to show, and we have clearly proved that. Is this clear, Tajdeed? Any problems so far from this part?
No, miss.
Okay, then just wait for a minute. Then we'll quickly move on to part A, and that is your numerical method or iteration part, right? Now they're saying that used in this equation, x is n plus 1. This is like the series in your AS physics or AS maths also. Like there they've already provided that x1 is 1. So using this value, try to find out x3. So we can easily calculate it. This time, the equations are given in this format. Like part E1, x1 was given as 1, and the expression here given was xn plus 1, 1 by 2, then 4 plus 3 e power minus xn whole square, everything under the square root. Now, if I insert x1 plus 1, that will actually give me the value for x2, and we're going to use half for e, so 3e minus 1 square, everything under square root, right? So from there we get the value 0.5 square root 4 plus 3 power minus 1 square. That gives you root 39 by 6. Okay, this is an approximate value that you get, root 39 by 6. So which is 39 by 6 root. That means I obviously have to insert this in my x3 value. This, by the way, gives you the value for your x3 also, right? So I should write this down. That this also, by the way, gives you the value for your x2. Okay, and then after this, for x3, we have to use x2, insert x2 in the equation. So we have half, then 4 plus 3e. This with the square will eventually become 39 by 6 only, right? So minus 39 by 6, everything under the square root. So if I just insert this in the equation again, just 1 minute. 39 by 6. Wait 1 minute. Wait, sorry, I'm actually getting a math error value for this. 1, 2, root 4 plus 3 exponential minus 1 square. Sorry, I made a mistake. This over here, the value for this was actually 1.12956. Okay. In this cases, it was already stated in the question that your answer should be to 4 decimal place. So I'm going to use the answer for x2 also as 4 decimal place. So 1.1296, 1.1296. Yeah. So you get 1.1296 whole square. So I'm going to insert that into the equation now. 1.1296, and that gives you the value for your x3, 1.09971. So up to 4 decimal place, this is 0.997, right? So you got your value for x3. Tajdeed, so far, is there any question from part E? Tajdeed, any questions from part E?
No, miss.
Okay, this was your part E1. Now for your part E2, what do we have to do is that just continue with the values for x3, x4, x5, x6 until or unless you get a constant value for your 4 decimal places. Okay, that's just it. For part 2, actually, the question was asking that find the value for A. How would you find the value for A from this iteration? Using the concept that we'll have to carry on with the x2, x3, x4, x5 until or unless we get the same value up to 4 decimal places. So if we start with x, I mean, we know that x1 is 1, x2 is 1.1296, x3 is 1.0997. Then x4 here, we'll have to calculate that, right? Just to use the calculator and replace this value with 1.0997. So from there, if I use my calculator, 0997, that leaves me with 1.1063. Okay, and then again for x5, still now I can see the values are all changing. They didn't give me any constant value, so I'll have to carry on with x5 also. So 1063, that leaves me with 1.1048. Same, still not any same value. So x6, that will be 1048, which gives you 1.1051, right? And then again x7, which is your 51, which is again 1.1051. We can see that 1.1051 is coming out as a constant value. Still, I will calculate this again, and we get exactly same, right? 1.1051. So we can see that x6, x7, x8, they have the same value. Why do they have the same value? That is the unknown value that I was trying to find out. So in that case, the value for your A will be 1.1051 according to 4 decimal places. So this is the working for your part 2. And this is the iteration maths, actually, or numerical method maths. For this one, you just have to use a series type of content that can insert x1 into this equation, that leaves you with x2, insert x2 in this equation, that leaves you with x3, and just follow the pattern until or unless the values get similar or exactly same. Whenever the value gets exactly same, that is the unknown value of the alphabet you are trying to find out. Is this clear, Tashdeep? Any problem from question 3?
Miss, what did you say? What it is called?
Iteration, numerical method. Right,
Like what?
these equations.
I wanted to know that
Mhm.
this finding this why are these values same after from
Oh,
like
because
6.
after 6, because in this equation, if you're inserting the same value in this equation, you're going to get the same value, right? If you're going to insert 1.105, then you're supposed to get 1.105. In the next case also, I'm inserting 1.105. So everywhere, if I'm going to insert the same value for x, I'm supposed to get the same value. So from this, after this, like since we got a repeatedly same value, everywhere we're going to actually have the same, same value will continue. Actually, in this case, I was getting 1.151, but in this case, I was actually getting 1.10505. But if you round that up to 4 decimal places, you restore the 51. So that's why there was slight difference. But when you limit that entire answer to 4 decimal places or 3 decimal places, then you get the same value. And with the same value, if it doesn't matter how many times you continue, you're supposed to get the same value over and over again. Is this clear, Tashdeep?
Okay, Miss.
Okay, so we are done with question 9. Then if you move on to your question 10, this is the last question. This is from exponential logs part. A population of fruit flies, number of fruit flies in the population after the start of the day is modeled by this equation. It says the number of fruit flies of the population at the start of the study. Start of the study means when t is equals to 0, right? So when your t is equals to 0, we're supposed to use the equation as if 350 e k 0 and then again 9 plus e k 0. So basically I have e power 0, e power 0. That's basically 350 divided by 10, right? So we get 350 over 10, which is just 35, and that is the work. After that, they're saying that given that there are 200 fruit flies, the value for your capital F is 200, and 15 days is the value for your time. Show that k is equals to 1 by 5, 1 by 15 ln 2, ln 12. So we're going to use the equation that, okay, this is your 200, then 350 e power 15k, then again 9 e power 15k. If you take this to the right hand side, so you basically have 200 e power 15k. 200 with 9 is going to give you the value of 1800 15k. Now take e power 15k to the same side. So basically have 300 minus 350 minus 200, right? So that's like how much? 150. 1800. From there you can write e power 15k is going to be 1800 over 15. So over 150. If you simplify that, I think that will give you the value for 12 or something. 1800 by 150 is actually 12. And we can now write this as k as 1 by 15 ln 12, right? Because when you take this exponential to the right hand side, that becomes ln 12 and divide by 15, so 1 by 15 ln 12. And this is your actual value for k. Okay, now we're done with part B also. For part C, they are saying that when the value for T was capital T, the number of fruit flies in the population is increasing at the rate of 10 per day. Increasing at the rate of 10 per day means that your df by dt is actually 10. Okay, that means you have to find out the expression for df by dt. You'll have to differentiate the equation. So for that differentiation, you have to do that fraction method or quotient method. So for if it was actually 350 e power kt plus 9 e power kt, right? So this is my u and this is my v. So u is 350 e power kt. So du by dx or dt is going to be what? This is going to be k e power, I mean, yeah, k e power kt. Oh, sorry, 1 minute. I mean, from there also I have to do the product method. 350, if you differentiate, that will be just yeah, I mean, this is how it turns. 350 d by dt, and then again we're going to multiply this with e power kt, and adding this with 350 with e power kt d by dt, right? So from there I can understand that this will be entirely 0 because this is 0. But from this part I get kt 350 e power kt, right? So I'll just k over here. So 350 k e power kt. This was the value for du by dx. For dv by dx, we have 9 plus e power kt. So we basically get k e power kt, right? 9 will be entirely vanished. So finally for df by dt, we get, and we're supposed to use actually capital T all this time. Okay, the value for your T here was capital T all this time. Okay, now if I use this, your what v du, v over here was 9 plus e power kt, and du was 350 k e power kt 9 plus e power k capital T, then minus u over here was your 350 e power k t, k e power k t, dividing this with v whole square, right? How much was v? V was 9 plus e power k capital T whole square. And now if I simplify this equation furthermore, I can understand that for both of them 350 e power kt is common, right? So if I take 350 e power k capital T, I'm supposed to get k 9k plus k e power kt, and from there I'm going to get minus k e power kt, dividing this with 9 plus e power kt whole square. I can clearly understand that this e power kt cancels out. So your 350 will be multiplied with 9. That gives you 3150 e power kt divided by 9 plus e power kt whole square, right? and this was equals to 10. It was given in the question that fruit fly is increasing per day, increasing rate was 10 per day, right? That means this df by dt was given as 10. So if df by dt is given as 10, let me take this denominator to the right hand side. So you get 350 e power kt 10, 9 plus e power kt. This 0 and 0 cancels out, leaving you with 350 EKT and 9 plus EKT. Take all the EKTs together. So you have 315 EKT minus EKT equals to 9. If you take EKT as a common factor, we get 315. Sorry, we get 314 EKT, right? Oh no, we cannot actually take this as a common. There was a square, so sorry, made a mistake. We're supposed to break down the square now. So it will be 81 plus 18 EKT plus EKT whole square over here. It's going to be, so KT whole square is going to be just 2KT. Okay, now again, after this, if I simplify the equation, you will have E2KT plus 18 minus 315, right? Yeah, plus 18 minus 315. But wait, yeah, we had a 9k here. So all this time we had this k e power kt. Right, so we have a k here, again k here. So we have, I mean, with this also, in the denominator over here, yeah, in that case, I'm going to get 315k e power kt, right? Because both of them were coefficients of e power kt. So 18 minus 315k plus 81 equals to 0. As you can see, now this is a whole square part. This is a EKT and this is a constant. This is exactly in a quadratic equation. If this is exactly in a quadratic equation, that means you can use the formula method to find out the value for exponential. So for the formula method, we basically get the formula method for EKT. I'll write down the expression here first, that EKT is going to be your minus 18 minus 315k and plus minus 18 minus 315k whole square minus 41c, everything under the square root, divided by 2, 1. And again, if I introduce a k over here, the value for k, which was 18 minus 315 multiplied with 1 by 15, or I can just directly write 315 by 15 ln 12 plus minus 18 minus 315 by 15 ln 12 whole square minus 481, everything under the square root, and then dividing this with just a 2, right? Remember that all this time you're getting the value for EK capital T, not the value for capital T. So if I simplify this expression, 18 minus 315 by 15 multiplied with ln 12, that actually gives you a decimal value. So you cannot actually calculate this in this pattern. I mean, you have to calculate this in all together in one fraction. So what I'll do over here is that I will write this fraction, and this was equals to exponential kt, right? So which means if I take this exponential to the right hand side, capital T over here is actually going to be ln, then with this ln you will have this entire expression, okay, and this entire thing will be further divided with your k, right? Because exponential becomes ln and k will become divided with this, so this is again divided with 15 ln 12. and this is only the positive version or negative version, right? That means we have to do the same equation for the negative version also, because I'm going to get two values for x, two values for this capital T. This is one solution, and the other solutions is going to be like this over here, where in between you have a minus sign now, right? So you just have to, like, carry your entire calculation like this in your calculator so that you get the accurate value. So ln minus 18 minus 315 by 15 into ln 12 this plus root over 18 minus 315 by 15 into ln 12, then whole square minus 4 into 81 divided by your 1 by 15 ln 12, and that gives you a value of 5.7. Okay, and then again carry on the same equation, but this time in ln minus 18 minus 315 into ln 12 divided by 15, and then again minus root over 18 minus 315 into ln 12 divided by your 15 value whole square minus 481, and then you have 1 by 15 ln 12. That leaves you with 20.78, so we can write 20.8 for this value. So we have these two values, 5.7 and 20.8. You have to carry on with this entire equation and then solve this equation. Is this clear? Tashdeek. This is a quite difficult, middle term over here, because we are working with so much big values, and I cannot just carry the decimals. Okay, in that case, the final answer will get modified. So we have to carry out all these values in together.
Yes, miss, it was quite
Lengthy, right?
lengthy.
Yeah, it was. Wait 1 minute, I'll stop the recording.